In the last video, we have looked at the definition of reduction and oxidation. We have looked at how we can obtain oxidation states of atoms in elements and compounds, which will allow us to know whether a substance has been oxidized or reduced. Now in this video, we're going to learn another new thing called oxidizing and reducing agents. Now one way to help you remember this better is I need you to think of secret agents. Do you all know secret agents? If you watch Hollywood movies, sometimes there are secret agents. So what does a secret agent do? Usually a secret agent is trained to kill people, right? But in a movie, usually what happens to them? They are killed themselves. So how does that help you to remember? Is that an oxidizing agent is a substance that oxidizes another substance, okay, but itself is reduced. A reducing agent is sent in to reduce another substance, but itself is oxidized. Okay, so before we go on to look at to elaborations on oxidizing and reducing agent, that is the one important thing that I want you all to remember. That an oxidizing agent oxidizes another substance, itself is reduced, and a reducing agent reduces another substance, itself is oxidized. So in a reaction, the easiest way to spot the oxidizing agent is to look for the substance that is reduced. And in a reaction, the easiest way to spot a reducing agent is to look for the substance that is oxidized. Okay, bear that in mind. It's very, very important before all the other definitions come in and cause you confusion. So before we look at all the other definitions, let's apply what we have learned to a reaction, which is this zinc plus copper 2 oxide to give you zinc oxide plus copper. Okay, so the question goes like this: identify the oxidizing and reducing agents in the reaction. So if you recall, the easiest way to identify a reducing agent is to find the substance that is oxidized in the reaction. So in the last video, we have seen that zinc is a substance that has been oxidized. So zinc is your reducing agent in the reaction. Similarly, what is the oxidizing agent? You have to recall that the oxidizing agent is reduced in the reaction. So the oxidizing agent is your copper 2 oxide. Okay, so please bear that in mind before I go on to the next part. Now, if you can recall oxidation and reduction, there are multiple definitions to it. So oxidizing reducing agent, we can define it from different perspectives or different angles as well. Okay, but when identifying, always go back to what is oxidized and reduced. So previously we have learned that there are different ways of defining oxidation and reduction. So along the same lines, there are different ways in which we can define oxidizing and reducing agents as well. So when we say that an oxidizing agent is reduced, what does it mean when a substance is reduced? Is that it has lost oxygen. So an oxidizing agent is one that donates oxygen to another substance. Okay. Similarly, when we say that an oxidizing agent is reduced, means that it has taken in hydrogen. Alright, so an oxidizing agent is one that accepts hydrogen from another substance. Similarly, when a substance is reduced, it takes in electrons, so it accepts electrons. An oxidizing agent accepts electrons from another substance. Okay. Next, reducing agent is oxidized. So when a reducing agent is oxidized, we say that it has gained oxygen. So a reducing agent is a substance that can accept oxygen from another substance. Similarly, it's oxidized when it loses hydrogen. So a reducing agent is one that donates hydrogen to another substance, and a reducing agent is also one that donates electrons. So it loses electrons and becomes oxidized. So these are the three other ways in which we can define an oxidizing and reducing agent, but it's not easy to use this definition, so always fall back to what is oxidized and reduced. However, it's useful. Why to know these definitions is because if you can recall, in the past chapters, have we learned any substances that readily donates electrons? That means they willingly give up their electrons. The answer is your alkali metals. Okay, so alkali metals, we have learned they are not stable, they are highly reactive, and they react by losing their electrons, by donating their electrons. That is why in the chapter on periodic table, we learned that alkali metals are good reducing agents. Along the same lines, do you recall any substance that reacts by taking in electrons? So they take in electrons and become stable. The answer would be your halogens. That is also why in the chapter of periodic table, we learned that halogens, they are powerful, they are good oxidizing agents because they accept electrons readily. Okay, now in a nutshell, anything that can be reduced, any substance that can be reduced can serve as an oxidizing agent. Anything that can be oxidized can serve as a reducing agent. Okay, in our syllabus though, there are two common oxidizing agents that you need to memorize and one common reducing agent that you need to memorize. So the two common oxidizing agents that we need to remember in the syllabus, they are acidified potassium manganate 7 and acidified potassium dichromate 6. Now what does it mean by acidified? It means that we have added an acid to it to make the solution acidic. Alright, as to why, we will learn in A levels that by adding an acid, we make the oxidizing agent more powerful. Alright, it becomes a more powerful oxidizing agent. And the one example that we need to remember for reducing agent is potassium iodide. Okay, so why are these examples very important? It's because of this. When acidified potassium manganate 7 acts as an oxidizing agent, itself will be reduced to Mn2+. Okay, if you don't believe, you can find the oxidation states of manganese. You will find that it has been reduced. And what is so special about this reaction is that potassium manganate 7 is purple. Alright, it has a very dark purple color, and manganese 2 ion is actually colorless. So when potassium manganate 7, when acidified potassium manganate 7 acts as an oxidizing agent, or when it's reduced, there will be an obvious color change from purple to colorless. Same thing for acidified potassium dichromate 6. When it acts as an oxidizing agent, itself will be reduced to Cr3+. Potassium dichromate 6 itself is orange. Okay, it has a distinct orange color, and chromium 3 ion is green. So when potassium dichromate 6 acts as an oxidizing agent, when it's reduced, there will be an obvious color change from orange to green. So for potassium iodide is the example that we need to remember for reducing agent. When potassium iodide acts as a reducing agent, itself will be oxidized to iodine. Okay, so we have learned in periodic table under halogens that halides are mostly colorless. Okay, whereas halogens are colored, and aqueous iodine is brown. So when potassium iodide acts as a reducing agent, when it's oxidized, there will be an obvious color change from colorless to brown. So up to this point, we haven't addressed the part where why is an obvious color change important? So why is the color change important is this. Now imagine I have a test tube, okay, which contains a solution, and I suspect that it contains an oxidizing agent in there. Okay, so how do I confirm that there's an oxidizing agent in there? Is that I add in a reducing agent. So what is the common reducing agent is this? Is your potassium iodide. Okay, so to confirm that an oxidizing agent is present, I add potassium iodide into the solution. And what happens if there's a color change? Now if the solution changes from colorless to brown, if there is a color change, what does it mean? It means that my iodide has been oxidized, meaning that there is an oxidizing agent in the solution. Okay, so to test for an oxidizing agent, we add in a reducing agent. If the reducing agent changes color, it tells us that the reducing agent has been oxidized. So indeed, there is an oxidizing agent in the solution. This is true if I have a test tube containing a solution and I suspect that there's a reducing agent in there. How do I confirm it? I need to add in an oxidizing agent. So for example, if I add in acidified potassium manganate 7, and after adding potassium manganate 7, the solution changes from purple to colorless. Alright, what does it mean? It means that the oxidizing agent has been reduced. It means that indeed the solution contains a reducing agent. So in order to test for a reducing agent, we need to add an oxidizing agent. If the oxidizing agent changes color, it tells us that indeed a reducing agent is present in the solution. So at this point, I hope you can see why are the two common oxidizing agents very important, because the color change will indicate to us that they have been reduced. And why is the reducing agent, why is the color change for the reducing agent important? Because if there's a color change, it tells us that the reducing agent has been oxidized.